Hello, hello, and welcome to a little video about the Unit 9 quiz review. Let's get started. In number 1 through 4, so this very first page, what we're going to do is we're going to match the statements and postulates to the images. Let's start with number 1. Now, number 1 is our only line, and lines are called segments. So let's take a look what we can figure from there. The first thing I see that jumps out at me is letter H, the segment addition postulate. Next, let's take a look at what's marked here. On my image, I have section RS and section ST. Let's find that. Oh, there it is in letter C. There we go, match those two up. Let's cross them off so I don't use them again. Okay, number 2. Well, number 2, 3, and 4 all have angles. So what I'm going to do is I'm going to name the angles and see how I can match it up. Here I have two angles next to each other, but they don't form a straight line. For our statement, I have angle YXZ and angle WXZ. I see that in letter D. Now, what letter D states is that when we add WXZ and ZXY, we get WXY. That's us just adding angles. So this is our angle addition postulate. Number 3 also has two angles next to each other. However, these two angles will form a straight line. This is going to be a linear pair. It's a pair that forms a line. So that's letter F on our postulates. Whoops. I got two options. GFH and KFH are supplementary, or that they're congruent to each other. Considering they have two different arch marks, I'm going to say letter A. They're supplementary. Also, supplementary means they add up to 180 degrees, because 180 degrees creates a line. On that note, we can kind of fill in the last two things. Our statement, GFJ is congruent to HFK. Those two angles have one arch each, showing that they have the same measurement. And that's our vertical angle theorem. Oh, postulate. Fantastic. Onwards we go. Well, let's work a little with these postulates. First, in letter A, what I see are two angles that form a straight line. This is our linear pair postulate. What a linear pair tells us is that we have supplementary angles. Supplementary means we add up to 180. So I'm going to set up this linear pair as 124 plus x minus 3 equals 180. All right, let's solve it. The first thing that I notice on my left-hand side are the two regular numbers, so I'm going to combine these like terms. 124 minus 3 is 121. So I'm left with x plus 121 equals 180. We only got one step left, which is fantastic. We need to subtract 121 from both sides of the equal sign, because we're undoing the plus 121. We are left that x equals 59. Perfect. Let's find x in letter, let's go in order. In letter B. If if angle EFG is 159 degrees, I like to fill that in, so that's a 159, and AFG is 5x minus 7, whoops, I read that wrong. Did you see me read that wrong? Crazy. Find x if EFG is 159. This is 159. Oh, Gumin. All right. AFG, this angle here, is 5x minus 7, and EFA is 16x minus 2. Well, this is our angle addition. We got two angles that form a bigger angle. Alright, so I've got 16x minus 2 plus 5x minus 7 equals 159. The magic of technology. Let's zoom in. All right, I got a bunch of like terms that I've got to combine. I have to combine the x's and the regular numbers. Let's do it. 16x plus 5x is 21x. Negative 2 minus 7 is minus 9. And we still equal 159. Next, let's add 9 to both sides. We're doing this to undo the minus 9. Okay. So, on the left, plus 9 minus 9 cancel. I only have 21x remaining. On the right, 159 plus 9 is 168. And then to finish up this problem, we're going to divide both sides by 21 because that's the number next to x. 21 divided by 21 is 1. Perfect. We just wanted a singular x. And 168 divided by 21 is 8. Perfect. Now let's take a look at letter C. Letter C, we have two angles across from each other. These are vertical angles. Vertical angles are congruent to each other, which means we can set this problem up as 85 equals x plus 25. This is a nice single-step problem where all we have to do is subtract 25 from both sides. And we get that 60 equals x. And finally, we got letter D. This is a segment. This is our segment addition. It looks like this whole segment is made out of 3 pieces, but altogether it's 23. So, if I do x minus 6 plus 9 plus 2x minus 19, I should get the full length of 23. Let's combine like terms. I got x and 2x. I got negative 6 plus 9 and minus 19. Let's start with those x's. X plus 2x is 3x. Next, we have negative 6 plus 9, which gives us 3. And then 3 minus 19 gives us negative 16. And we still equal 23. We only have 2 steps here. Let's add 16 to both sides to undo the minus 16. Minus 16 plus 16 is 0, so we have 3x equals. On the other side, 23 plus 16 gives us 39. Got one last step to get x by itself, and that is to divide both sides by 3. 3 divided by 3 is 1, perfect. X equals 13. So on this page, we used every single one of these statements to do a little bit of algebra in our geometry. Now let's do the next section where we learned about triangle congruencies. So in these 4 problems, I don't know why I have that extra page at the end, we are going to state if the triangles are congruent. If yes, we're going to complete statements 1 through 4. If no, we're just going to complete statements 1 through 3. Okay, so in number 5, I have 2 triangles. Let's see what they both have. They both have this angle. They both have this side. And they both have this angle. We have angle. Whoops. We've got angle, side, angle. They're congruent. Let's write our statements. Let's begin with that pink given angle, the one I started with. On the left triangle, I'm going to name it angle BAE. On the right triangle, I'm going to call it BCE. BCD. Next, let's talk about the sides. On the left triangle, I'm calling this side AE. On the right triangle, it's side CD. And then let's take care of that last angle. I'm going to call it angle AEB. And on the right triangle, I'm going to call it CDB. And that's another given angle. Let's name this triangle on the left. I'm going to call it triangle BAE. And on the right, I'm going to call it triangle BCD. They are congruent by angle, side, angle. All right, number 6. Let's see what they both have. Right? I noticed they both have an angle. They both have a single side. And then they both have a double side. Uh-oh. What do we got here? We have an ASS. Unfortunately, this is not a triangle congruency. So we're going to fill out statements 1 through 3, but we can't fill out number 4. These are just two triangles that happen to have some similar given sides and angles. Let's start with that angle. On the left triangle, I'm going to name this angle LJK. On the right triangle, I'm going to name it angle STK. And this is a given angle. Okay. Next, let's talk about that side. I have side LJ. And I have side ST. And lastly, I have side LK and side SK. Oh, I forgot to circle no. All right, onwards we go. Ooh, I wanted to mention, in number 6, if this was to be congruent, the angle should have been right here. The angle for side angle side must be in between the two sides. For example, in number 7, we have an angle in between two sides. This is a proper side angle side. We got the green side that I marked, and the purple side that I marked, and in between the green and purple side, I have that pink angle. Let's start with that green double side. Let's start with the top triangle. They are congruent, yes. Okay. On the top triangle, we have QR congruent to SR. Now let's do the angle. On the top, I'm going to call it angle PRQ. And for the bottom angle, let's call it TAS. Okay. Now let's do that second side. We've got PR on top. Now we've got TR on the bottom. And lastly, let's name our triangles. I'm going to call the top one triangle PRQ. And the bottom one, I'm going to call it TRS. and they are congruent by side, angle, side. Lastly, let's take a look at number 8. What does number 8 have? Well, number 8 has a single angle, a double angle, and a triple angle? AAA is not a congruency. Unfortunately, we can only have an SSS congruency. All sides, that works. All angles, not a congruency. So we can't fill out statement 4. However, let's practice naming our angles. Let's begin with the single arches. On the left, I'm going to call it angle HSQ. On the right, I'm going to call it FEQ. Next, let's do the doubles. I have SHQ on the left and EFQ on the right. And then finally, let's do those triple arched angles. On the left, I'm going to say HQS. And on the right, let's do FQE. Okay, and there we are. Right? Yeah, this is just a blank page I have for some reason. If you have any questions, please make sure to ask me or whoever else is helping you out with this. And good luck on your quiz. Bye.